Hi, my name is IFFAH. My group and I will represent regarding Sungrow's power supply. The company's dedication to reinventing its production procedures and putting sustainability at the center of what it does is represented in this initiative. The goal is to provide cutting-edge power supply solutions that seamlessly support the business sustainability objective. With this initiative, Sungrow Power Supply is entering a new age of environmentally aware production, marking a paradigm change. For the project methodology, there is 7 parts, which is creative solutions that consist of Sungrow's transformative journey focused on innovative power electronics such as SiC and GaN, diverse circuit topologies and hybrid power system, promising a sustainable future. Secondly, advantages and challenges. Efficiency gains, reduced heat dissipation and downsizing are explored, while design complication and EMI concerns are addressed for a balanced approach. Next, eco-friendly components consists of life cycle research evaluates environmental impacts, comparing suggested alternatives with conventional designs to guide responsible decision making. Furthermore, sustainability assessment. Evaluation of long-term benefits aligns with Sungrow's environmental goals, emphasizing compliance with international standards and reduced resource use. Next are end-of-life consideration. Recycling methods and components designed for prolonged lifespan minimize environmental impact, contributing to sustainability. Adding the implementation strategy, anticipating production challenges, training programs and reliable supply chain from vendor connections ensure a smooth transition to sustainable practice. Lastly, cost-benefit analysis. A comprehensive analysis highlights the financial advantages of reduced energy costs and improved consumer perception, reinforcing Sungrow's commitment to sustainability.
This slide is showing a simulation circuit from a schematic. We're using 4 multimeters to measuring the voltage at the capacity C1 with C5 and C3 with C7. Then we utilize the oscilloscope to measuring the peak value by connecting the circuit on between the Vs and T1. And then we're setting the scale at channel A and channel B in oscilloscope to 400 voltage per diV before running the circuit, and set the yellow line located to the peak value at the frequency line. In voltage regulator output measurements, we measure the output voltage waveforms of the U1 and U2 regulators. The U1 and U2 will regulate the voltage to positive and negative. Then in the output voltage measurements, we measure the final output voltage waveform and confirm that the final output voltage matches the desired specifications. For current measurements, we measure the current through the key components such as the transformer primary, secondary, and regulator inputs or outputs. At the last is waveform analysis. We analyze the waveform for any anomalies, overshoots, or distortions, ensure that the circuit is functioning as expected under various conditions. This slide is showing the selection and justification of the simulation component values, and the first is needed to measure the voltage across the AC source. Then in transformer windings measurements, we need to measure the voltage waveform across the primary and secondary windings of the transformer. And for the rectified DC voltage, we measure the voltage waveform after the diodes in the rectified circuit, because the function of the diode is to convert AC to pulsating the DC. After that, in filtered DC voltage, we measure the voltage waveform after the smoothing capacitors, because the capacitors will ensure the ripple voltage is reduced and the average DC voltage is stabilized.
I am going to present the functionality of the simulation circuit and the simulation result measurement. Here in this diagram, it has 3 component measure, which is power sources, oscilloscope, and transformer. For power sources, it supplies 240 VRMS 50 Hz and maintains a steady voltage regardless of the amount of current passing through it. It is also connected to the transformer T1. For oscilloscope, the channel's positive terminal is connected to the power sources VS 240 VRMS. The peak value for the voltage channel A is around 339 volts, which is the same with VRMS equal to 240 volts. For transformer, it transfers the electrical energy that shows the value of 1011. It also shows resistance of 10. The transformer, also known as a step-down transformer, as the voltage was decreased from V1, that is 240 volt, to V2, which is 24 volts. Next, for this diagram, it is about oscilloscope results. It shows the signal change over time between T1 and T2. The sum of the voltage measurement, which is 566 and 766 volt, and the difference between time, which is 12.581 milliseconds. It also shows the channel coupling between channel A and B that share the same DC component, which means the DC coupling retains both AC and DC component. Then for this diagram, the diode consists of D1, D2, D3, and D4 with the value of 1 and 4002G. It is also connected to the capacitor of C1, C2, C5, and C6. Meanwhile, the diode is C1, C5, C2, and C6. The value of C1 and C5 is 2200 microfarad, meanwhile C2 and C6 is 0.1 microfarad. Capacitor is to store the charge, and it is connected to the multimeter's XMM1 of 33.138 volts, and XMM2 is negative 33.13 volts. The multimeter will measure the capacitance of the capacitors. Next, the voltage regulator shows the voltage here in this diagram is 13.3 volts, and it is to keep the output voltage constant within a given range. The capacitor then were continued with capacitor C3, C4, C7, and C8. Both C3 and C7 is showing the value of 100 microfarad, and C4 and C8 is 0.1 microfarad. It were connected to two multimeter, which is XMM3 of 12.571 volt and XMM4 of negative 12.61 volt. In conclusion, the voltage output here were positive 12 volt and negative 12 volt. The positive and negative output is caused by U1 and U2 regulator, since U1 is positive and U2 is negative.
Hello doctor, my name is NAJIHAH and I will be continuing the presentation with discussion. In discussion, the first part that I'll be explaining is creative solution. My team has come up with two solutions that we believe will make a better circuit. So the first is to utilize gallium nitride transistors. Because using gallium nitride, we can achieve higher switching frequency. Besides that, using gallium nitride, we can reduce the size and the weight of the transformers while enhancing the efficiency. Compared to without using gallium nitride, it would have been heavier and the switching frequency would be slower. Next, using gallium nitride can also reduce in greenhouse gas emissions associated with power generation and transmission. And since the creative solution, we are supposed to come up with a creative solution that can enhance efficiency and reduce environmental impact, my team believes that utilizing gallium nitride would be one of the best solutions to make the circuit better. The next creative solution that my team has come up with is explore resonant power supply topologies. So there are two that we can explore. Firstly is zero voltage switching, and secondly is zero current switching. So this can minimize the electromagnetic interference EMI compared to the regulator-based circuit, the previous circuit, that would often need additional filtering components. What I mean in this is the three-terminal IC voltage regulated base circuit, they generate a significant EMI in their switching waveform. That's why they will need additional filtering components. But if we use resonant power supply topologies, we have a lower electromagnetic interference, which make it as a viable solution for EMI reduction. So it will be a better circuit. That is all for me for creative solution. Now I'll be explaining for the discussion part 2, which is the advantages and challenges for two of the creative solutions that I've mentioned earlier in the slide. So firstly, for gallium nitride transistors, the advantages, there are many. Firstly is lower switching losses, decreased heat dissipation. Again, when you decrease heat dissipation, you're reducing environmental impact since there is lesser needs for cooling effects. And since gallium nitride is smaller transformers, it will result in a lighter overall system. And it's also suitable for dynamic loads and transients performance. But one of the challenges is if you have a tight budget, it might be hard to be able to use gallium nitride transistors because these transistors is currently more costly than their silicon-based counterparts. It's also more expensive than the previous circuit, but in the long run, it is definitely more worth it, as it can enhance efficiency and reduce environmental impact, which is the two very important points in our creative solution. For the next point is the resonant power supply topologies, which is the ZVS and the ZCS. So again, the advantages is many and almost similar like the gallium nitride, which is it reduces switching losses, increase efficiency, lowering heat dissipation, of course reduce environmental impact, reduce switching noise, reduce EMI, reduces voltage and current stains on components. Hence, this can boost the dependability and longevity. So these 2 points is very important because we want it to be worth it in the long term and also enhance efficiency and reduce environmental impact. So in the long run, it's definitely worth it to use this solution in the circuit. One of the challenges is it will require accurate component selection and tuning, and this will make the design more complex. So it may be more difficult, it may be more costly, but again, in the long run, it is very worth it. So that is all from me for discussion.
Hi doctor, my name is Siboni and I'll be explaining about the discussion which is the eco-friendly components and sustainability assessment. First is the material selections. So traditional components often involve resource-intensive processes, but here's where the game changes. Eco-friendly alternatives prioritize sustainable sourcing, significantly reducing our environmental impact. This aligns seamlessly with responsible material management, crucial in combating climate change. So it's very important to select the right material for certain components because it could bring harm to the environment. If you use a better material, it could able to fight against the climate change. Next is the manufacturing impact. So the manufacturing impact process is a key player in our sustainability journey. Conventional design, which is a traditional design, often contributes to increased emissions through energy-intensive productions. For example, you can see that all these industries, they always produce all those thick smoke or gases from their factory. So this is very important to use innovative technologies to be able to produce those eco-friendly components. So to enter the eco-friendly components, it should be cleaner, more efficient. Manufacturing should also try to reduce those operational impact by prioritizing operational efficiency becomes the paramount in our transition to sustainable power supply. Last but not least, it's the durability and circular economy. So let's talk about durability. Eco-friendly components makes a crucial appearance here because they are able to improve the durability and extended their lifespans. So in their roles, this is are able to directly reduce those electronic wastes. So by using those components they are able to use for a long time are able to help us to reduce the waste. So when we compare this with traditional designs, it emphasizes a significant move towards a circular economy. These transitions represent a crucial turning point, promoting responsible consumption and disposal practices in power supply circuit design. And next, I'll be talking about end-of-life consideration. So first, it's the decomposition and recycling. So normally nowadays, we often use the more eco-friendly materials compared to traditional components because traditional components often pose challenges in disposal because they can't self-dispose and due to their hazardous materials. So in contrast, eco-friendly designs take a responsible approach to decomposition and efficient recycling, reducing the environmental impact. And next is the disposal methods. So for components that cannot be recycled, they should incinerate under the emission system, where emission capturing system is the one that able to absorb those carbon dioxide. Because burning those materials could be harmful because it releases all those gases and as well as toxics. Most reliability is that most relatable is that the carbon dioxide because it's very harmful to our environment. So by burning down those materials, those components that cannot recycle, but at the same time, we should provide a solution which is to use a system where the emission system that are able to solve this problem. However, landfill disposal is the last straw for this disposal method because of certain components that cannot really be burned also should be buried under the landfill. So it's like they're digging a hole, so they throw those components inside the hole and then they just bury it inside the ground. So it could actually brings a lot of potential harms, especially environmental hazards to the environment. So eco-friendly designs mitigate these by using less toxic materials and lead to a more responsible waste management. And next is the circular economy and EPR. So EPR is a short form of extended producer responsibility. It's a kind of policies for environmental. For this point, a transition to a circular economy is crucial because designing components for recyclability and reusability becomes the central to this transition. So extended producer responsibility, known as EPR policies, is to ensure that the manufacturers actively manage products throughout their entire life cycle and reducing the environmental impact. Last is the implementation strategy. So first is the progressive implementation strategy. So when it comes to adopting sustainable designs, our approach is all about taking small, impactful steps. You are suggesting incremental adoptions, allowing us to manage production costs effectively by pursuing economies of scales, negotiating bulk discounts, and exploring government incentives. We ensure a steadfast commitment to our environmental goals while smartly mitigating initial expenses. The second one is the supply chain collaborations. So we should be able to work together with supply chains to overcome these challenges in material availability and as well as scarcity. And we are talking about those collaboration, right? So we should working closely with reliable suppliers, conducting tariff market research, and investing in supply education programs. We are establishing a varied and robust supply chain. This ensures consistent resource availability, a key element in our journey towards sustainability. The third one is the technical integration and employee training. So now let's talk about staying ahead in technology. Our employee training programs ensure our workforce is proficient in handling new technologies. So collaborating with technical specialists and implementing continuous improvement projects optimize our integration process, fostering a corporate culture of adaptability and innovation. So that's it from me. Thank you.
So now I will be covering the cost-benefit analysis. So on this slide, we are conducting a cost-benefit analysis comparing the initial investment and operational cost of traditional and innovative designs. So looking at the traditional power supply designs, so it involves components like transformers, diodes, and IC voltage regulators. So initial investment cover procurement costs and their ongoing operation expenses, including energy consumption and maintenance. The benefits of the traditional design, including simplicity, years of production and familiarity within the industry. So let's look at the innovative power supply design. Here we explore alternative components, novel circuit topologies, and energy-saving features. The initial investment might be higher due to the novelty or eco-friendly nature of these elements. However, operational costs are evaluated with a focus on potential saving from improved energy efficiency and reduced maintenance. So the key benefits of the innovative design revolve around advancements in energy efficiency and reduce environmental impact, contributing to potential long-term cost savings. So in summary, our analysis involved in side-by-side comparison of the traditional and innovative design. So we are looking at initial investment, ongoing operational costs, and the return of its investment. So we will also consider qualitative factors like alignment with sustainability goals. So our goal is to provide a well-substantiated recommendation for Sungrow Power Supply Company. Thank you. So in conclusion, let's recap our key findings and contributions. So innovation with GaN transistors, our commitment to efficiency shines through the integration of gallium nitride transistors, pushing boundaries and reducing environmental impact. So eco-friendly components and sustainability. We are carefully choosing eco-friendly components and debates end-of-life plans, aligning our project with environmental responsibility and reducing our footprint. And next is strategy implementation. Our coming challenge, our implementation strategy focuses on cost effectiveness and robust supply chains, ensuring the seamless transition to sustainable practice. So next one is cost benefit analysis, guiding decisions. Our detailing cost benefit analysis has been the compass guiding us, allowing us to make informed decisions based on both financial metrics and sustainability goals. The next one is pioneering sustainable practice. Sungrow Power Supply is not just a dominant change, it is pioneering sustainable practice and innovations, setting a positive example for the industry. So in conclusion, our journey is not just about improving power supply solutions, it's about embracing a greener, more sustainable future. Sungrow Supply stands at the forefront of this revolution, proving that innovation and sustainability can go hand in hand. Thank you.